Welcome into the next video in my series on essential skill number 1 for AP Chemistry, dimensional analysis and mole conversions. So in this video, I'm going to cover a new type of conversion involving a gas at STP. Now STP, as we see here, means standard temperature and pressure, and that the values of that for an ideal gas are 0 degrees Celsius for the temperature, or which is the same thing as 273.15 Kelvin, and 1 atmosphere for pressure. Now, when we are at STP, it turns out that 1 mole of a gas has a volume of 22.4 liters. This is how that information is presented on the AP Chemistry formula sheet. Okay, a negative first exponent means it's in the denominator, so this is saying 22.4 liters per mole, okay, which is the same thing as this. And we can verify that this relationship is true by simply using the ideal gas law. So if we rearrange for volume and then plug in 1 mole, plug in the constant for R, and then plug in our standard temperature and pressure, temperature needs to be in Kelvin when we're using the ideal gas law, you get 22.4 liters. So that checks out. That's where that number comes from. But it's going to be useful to just, either memorize that conversion, or of course, if you have the AP Chemistry formula sheet, it is given to you, and to be able to just know how to use that kind of directly, which we'll cover in this video. We can only use it when we're at STP. My next video is going to be how to do similar problems to the ones we're doing in this video when we're not at STP. We have to do it a different way. Okay, so because of this relationship, we can use this as like a conversion factor in a dimensional analysis calculation between moles and liters if we're talking about an ideal gas at STP. So we're going to look at two similar but slightly different examples in this video. So in the first case, they're both going to be stoichiometry examples. Okay, and in both cases, we're going to have to apply this conversion. But in this first example, we're going to be finding the liters of a gas, finding the volume of a gas at STP. And so the way that we would do that and incorporate this conversion is we would first do a regular stoichiometry calculation to get into the moles of the gas. And then we would go ahead and use our 22.4 liter per mole conversion to go from moles to liters. Okay, so in this example, we're given the grams of calcium. We're trying to find the liters of oxygen. So our last step, the way we're going to get into liters of oxygen, is we're going to go moles to liters. So that's going to be our last step, is moles of oxygen to liters of oxygen using the 22.4 liters in 1 mole, which we can do because we're at STP. Okay, so then before that, we have to just do regular stoichiometry. So we're starting with grams of calcium. We can then convert that to moles of calcium, do our mole to mole conversion, and then we can do that mole to liter conversion as the last step. Okay, so start with 5 grams of calcium, convert that to moles by dividing by the molar mass, which is 40.08 for calcium. Okay, and then we have to do our mole to mole step. So don't skip this step, okay? 2 reasons we need to do this step. One is that we're finding the amount of oxygen, okay? So when we do the mole to liter, it has to be an oxygen for 2 reasons. Number 1, because we're finding the liters of oxygen, but just in general, it has to be a gas. We can't use the 22.4 liters in 1 mole if it's not a gas. Calcium isn't a gas, it's a solid. Okay, so we don't want to be in calcium anyways, we want to be in oxygen anyways, but just keep that in the back of your mind, is that 22.4 liter in 1 mole conversion is only valid if it's a gas, and the only gas in this reaction at all is oxygen. So grams of calcium cancel, and then the mole to mole step. So moles calcium on the bottom, moles oxygen on top. We convert moles to moles using their coefficients, which are 1 and a 2 respectively. Okay, that would give us our moles of oxygen if we stop there. And now we're going to go ahead and do this mole to liter conversion that we've been talking about. So moles of oxygen on the bottom, liters of oxygen on top, and there are 22.4 liters in 1 mole of a gas at STP. So we can go ahead and use that conversion. And then we can go ahead and calculate, multiply along the top, divide along the bottom. I gotta go get my calculator real quickly. We get 3 sig figs, 1.40 liters of oxygen gas. And then in this example here, we're sort of doing the opposite. We're starting with the liters of the gas, and we're trying to calculate the grams of something else. So in this case, we would use the liter to mole conversion first to get into moles. And then once we're into moles, we can go ahead and just do kind of a regular stoichiometry calculation that we're familiar with from there. Okay, so this example, very similar. Essentially, we're just going in reverse. So now we're starting with the liters of our gas at STP. So we're gonna start with that liter to mole conversion to get into moles, and then we can do regular stoichiometry. So moles of O2 to moles of calcium, and then moles of calcium to grams of calcium. That's going to be our setup. So essentially, like moles is kind of our standard unit to be in for stoichiometry. And then liters, we haven't really seen this in these stoichiometry problems so far. So it's just we've introduced a new way to convert into and out of moles. And so we're going to attach this on either at the beginning or at the end, depending on what we're starting with and what we're going to. So in this case, we're starting with liters. So we're going to attach that liter to mole conversion at the very beginning to get into moles, and then make it sort of a more familiar stoichiometry calculation. So liters on the bottom, moles on top, and again there are 22.4 liters in 1 mole of a gas at STP. Again, we can only use this when we are at STP, but we are for this. Again, in my next video, cover how to do it when we're not at STP. And then the mole to mole conversion, moles O2 on the bottom, moles calcium on top, 2, 1. And then moles to grams. This time molar mass is going to go on top. And let me check my calculator. That's going to be 17.9 grams of calcium. So hopefully that makes sense how to incorporate that 22.4 liters to 1 mole conversion when we're at STP for a gas, and how to kind of go in both directions.